Hello everyone. Today we are going through equation of a line in three-dimensional space. So here in this section we will study how to find the equation of a line in three-dimensional space. So first one, equation of a line through a given point and parallel to a given vector. That is, how to find the equation of a line when a point on the line and parallel vector are given. See here in three-dimensional space, see x-axis, y-axis, z-axis, it's a line in the space, okay. So here we are going to find the equation of this line, okay. So here what are given? A point on the line and parallel vector, okay. So let's take a point on the line. Let this line passes through a point P, okay, a point P. So let's join this. So now it is the origin. So vector OP, that is the position vector, okay, position vector OP. And let's take another point A. Let's join this. So it is the position vector OA. Let vector OP is equal to vector R and vector E. And one more thing is given, parallel vector. Okay, here we are going to find the equation of a line when a point on the line is given and parallel vector is given. Okay, so here parallel vector is given. See here, let's take this parallel vector B. Okay, so here we can write, see, vector, it is vector A, it is vector R, okay, vector OP, vector AP, okay. See here, since these two vectors are parallel, we can write vector AP is equal to lambda into vector B, right? Because these two vectors are parallel. We have learnt it in vector algebra, okay. So here, since these two vectors are parallel, vector AP is equal to lambda into vector B, okay. Now, then by the triangular law of vector addition, here we can write what is vector AP? By triangular law of vector addition, we can write vector AP is equal to vector OP minus vector OA, right? Why? Because see here, by triangular law of vector addition, vector OA plus vector AP, that is equal to vector OP, right? So from this equation we will get vector OP minus vector OA, that is equal to vector AP, okay. So vector AP is equal to vector OP minus vector OA. So what is vector OP? Vector R. Vector R minus vector A, that is equal to vector AP is lambda into vector B. That is, this can be written as vector R is equal to lambda vector B plus vector A. Okay, or we can write vector A plus lambda vector B. Okay, so here see, it is the equation of a line. Okay, and this, see here, equation is in vector form, right? Vector R is equal to vector A plus lambda vector B. Therefore, vector equation of a line is given by vector R is equal to vector A plus lambda vector B. Very important. Remember, vector equation of a line is given by vector R is equal to vector A plus lambda vector B. Now, let's see how to write the equation in Cartesian form. Okay, see here it is the vector form. So next, let's see how to convert this vector form to Cartesian form. We have got vector equation of a line is vector R is equal to vector A plus lambda vector B, right? So here, let's find Cartesian equation of the line. Okay, so here for that, let P be a point P of x, y, z. Okay, and A be a point A of x1, y1, z1. Okay. And here let A, B, C be the direction ratios of the line. Okay. Direction ratios of the line. Okay. So here we have the equation, right? Equation of the line. So let's substitute. Okay, first of all, let's find what is vector R. Vector R is nothing but vector OP, that is position vector of P. P is the point XYZ, right? So what is the position vector? Vector OP or vector R is equal to vector OP, that is nothing but XI plus YJ plus ZK, right? Okay, then here what is vector A? Vector OA, and A is the point x1, y1, z1, right? So here vector OA, vector A is equal to vector OA, that is equal to x1 I plus x2 j plus y1 j plus z1 k. Now what is the vector B? See, vector B is nothing but vector B is equal to, see, A, B, C are the direction ratios of this line. Okay, since these two lines are parallel, here vector B is nothing but AI plus BJ plus CK. Okay, now let's substitute this in this equation. It's our equation of the line, right? So let's substitute in equation 1. So we will get vector R, that is xi plus yj plus zk, that is equal to vector A x1i plus y1j plus z1k plus lambda into vector B, that is ai plus bj plus ck. Okay. Now let's compare left side and right side. Okay. See here I coefficient is x, right? Here I coefficient is x1 plus a lambda, right? So here let's compare. So x is equal to x1 plus a lambda. Next y is equal to y1 plus b lambda. Okay, coefficient of j in LHS y and in RHS y1 plus b lambda, right? y1 plus b lambda. Next z is equal to coefficient of k in LHS is z and coefficient of k in RHS is z1 plus c lambda. Okay, z1 plus c lambda. Okay, so here first equation can be written as lambda is equal to x minus x1 divided by a, right? Here second equation, lambda is equal to y minus y1 divided by b, right? Third equation, lambda is equal to z minus z1 divided by c. Okay, so here all the equations that is equal to lambda, right? Therefore this can be written as x minus x1 divided by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c. It is the Cartesian equation of line. Okay, it is the equation of a line in Cartesian form. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Next one is equation of a line passing through two given points. Okay, here we will find the equation of a line when 2 points on the line are given. Okay, so here consider this line passing through 2 points A of x1, y1, z1 and B of x2, y2, z2. Okay, and let P be any point on this line. Okay, let P be any point on this line, and with the position vector R. Okay, and here the vector OA, vector OB. Let vector OA is equal to vector A and vector OB is equal to vector B. Vector OP is equal to vector R. Okay, so here see, vector AB and vector AP are collinear, right? Parallel vectors. Vector AB and vector AP. Okay, vector AB and vector AP are parallel collinear vectors. Therefore, here we can write vector AP is equal to lambda into vector AB, scalar multiple of vector AB, right? So here, why? Because vector AB and vector AP are collinear vectors. Okay. Then, here by triangular law of vector addition, we can write what is vector AP? Vector AP is equal to vector OP minus vector OA, right? And what is vector AB? Vector AB is equal to vector OB minus vector OA, right? So let's substitute this here. That is vector OP minus vector OA is equal to lambda into vector OB minus vector OA. Okay. See, this we have written from the triangular law of vector addition. Okay. So here vector OP minus vector OA is equal to lambda into vector OB minus vector OA. What is vector OP? That is vector R. Vector R minus vector A is equal to lambda into vector B minus vector A. Okay, that is vector R is equal to lambda into vector B minus vector A plus vector A. Okay, so here it is the vector equation of a line passing through two given points with the position vectors vector A and vector B. Okay, see, what are vector A and vector B? Vector A and vector B are the position vectors of given points. Okay. Okay, we have got vector equation of a line passing through two given points, right? That is vector R is equal to vector A plus lambda into vector B minus vector A. Here vector A and vector B are the position vectors of the given points. Okay. So here now let's find Cartesian equation. Cartesian equation of a line passing through two given points. See, if you know the vector equation, you can convert this to in Cartesian form. Okay. So here substitute, just substitute. See, what is vector R? It is the position vector of P, point x, y, z, right? Therefore, what is the position vector? We can write vector R is equal to xi plus yj plus zk, right? That is equal to vector A. Vector A is the position vector of A, right? A is the point x1, y1, z1. Therefore, this can be written as vector A is equal to x1i plus y1j plus z1k plus lambda into here B minus A. What is A? Vector B. Vector B is x2i plus y2j plus z2k. Because vector B is the position vector of vector B. B is the point x2, y2, z2, right? So here B is nothing but x2i plus y2j plus z2k. So what is B minus A? That is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k, right? So here let's compare coefficients, right? X here in LHS coefficient of I is x and here coefficient of I is x1 plus lambda into x2 minus x1, right? So here let's compare. X is equal to, first of all, coefficient of I, okay, comparing on both sides. I, coefficient of I is x. Here coefficient of I is x1 plus lambda into x2 minus x1, okay, x1 plus lambda into x2 minus x1, Okay. And next, comparing the coefficient of y on both sides, that is, sorry, coefficient of j. Okay. So here coefficient of j in LHS is y is equal to, here coefficient of j in RHS y1 plus lambda into y2 minus y1. Okay, y1 plus lambda into y2 minus y1. And z is equal to z1 plus lambda into z2 minus z1. Right? That is, coefficient of k in LHS is z and coefficient of k in RHS z1 plus lambda into z2 minus z2. Okay. So here we can write it as, this implies lambda is equal to x minus x1 divided by x2 minus x1. Right? Take this x1 here. So here we will get x minus x1 is equal to lambda into x2 minus x1. Therefore, lambda is equal to x minus x1 divided by x2 minus x1. This equation implies lambda is equal to y minus y1 divided by y2 minus y1. This equation implies lambda is equal to z minus z1 divided by z2 minus z2. Okay. So this can be written as x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1. Why? Because all these equations are equal to y, right? Okay. So that is equal to z minus z1 divided by z2 minus z1. So it is the Cartesian equation of a line passing through two given points. Okay. When 2 points on the line are given. Okay, next we are going through angle between two lines. Okay, just now we have studied that equation of a line when a point on the line and parallel vector are given is vector r is equal to vector a plus lambda vector b. Right? It is the equation of a line when a point on the line and parallel vector are given. Okay. So here what is the parallel vector? You just go through the equation of a line when a point, that is passing through a point and a parallel vector, given parallel vector. So here it is the vector b. We have taken vector b is the vector b as the parallel vector. Right. So here this vector b is parallel to this line. Right. This vector b is the vector b is parallel to the line. Right? It is the line. Vector r is equal to, it is nothing but vector r is equal to vector a plus lambda vector b is the equation of a line. Right? And here vector b is the parallel vector. So here we can say this vector is parallel to this line. Okay. Now here we have to find the angle between two lines. Okay. So suppose these are the lines. Okay. Vector a and okay, so it is the line vector r1 and vector r2. Okay, vector r1 is equal to vector a1 plus lambda b1. Okay, vector a1 plus lambda vector b1. Vector r2 is equal to vector a2 plus lambda vector b2. Okay, so here we have to find the angle between them. That is, angle between these two lines, vector r1 and vector r2. And see here, so okay, here vector r1 and is equal to a1 plus lambda vector b1 and vector r2 is equal to vector a2 plus lambda vector b2 are two lines. Okay, then here we have to find the angle between them, right? And we know that, see, vector b1 parallel to this line, right? Okay, vector b1 parallel to this line, that is vector r1. Okay, and vector b2 okay, vector b2 parallel to vector r2, vector b1 parallel to vector r1. Okay, Why? Because here we know that, see this line, it is the line, here vector B is the parallel vector, therefore we can say vector B, this vector B parallel to this line, right? So similarly, here vector B1 and vector B2 parallel to vector R1 and R2 respectively, okay? So here it is enough to find the angle between vector B1 and vector B2, okay? Because their angles are same. Okay, angle between B1 and B2, angle between R1 and R2 are same. Why? Because they are parallel. Okay, vector B1 parallel to vector R1 and vector B2 parallel to vector R2. Therefore, their angles are same. Okay, so here it is enough to find the angle between vector B1 and vector B2. So what is the angle between two vectors? That is cos theta is equal to vector B1 dot vector B2 divided by modulus of vector B1 into modulus of vector B2. Okay, cos theta is equal to, so what is the angle? Theta is equal to cos inverse of B1 dot B2, that is vector B1 dot vector B2 divided by modulus of vector B1 into modulus of vector B2. That is the angle between vector B1 and B2. Therefore, angle between two lines is the same thing. Okay, theta is equal to cos inverse of vector B1 dot vector B2 divided by modulus of vector B1 into modulus of vector B2. Okay, so here it is in vector form. So how to write it in Cartesian form? Here you just substitute what is vector B1. See, in our first derivation we have written vector B is equal to, here vector B is equal to AI plus BJ plus CK. Here A, B, C are the direction ratios of the line. Okay, direction ratios of this line. Okay, therefore vector B parallel vector B is equal to AI plus BJ plus CK. Right? So here B1, vector B1 is equal to A1I plus B1J plus C1K. Therefore, here we can write cos inverse of, what is the dot product? That is, see here B1, vector B1 is equal to A1I plus B1J plus C1K. Okay, that is A1, B1, C1 are the direction ratios of R1. Okay, and vector B2 is equal to A2I plus B2J plus C2K. Here A2, B2, C2 are the direction ratios of the line vector R2. Okay, line R2. So here what is vector B1 dot vector B2? A1, A2 plus B1, B2, right? A1, A2 plus B1, B2 plus C1, C2 divided by modulus of vector B1, that is nothing but root of A1 square plus B1 square plus C1 square, right? So root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So it is in the Cartesian form. Okay. So here theta, that is angle between two lines, is theta is equal to cos inverse of vector B1 dot vector B2 divided by modulus of vector B1 modulus of vector B2. Here vector B1 and vector B2 are the parallel vectors. Okay, parallel vectors of vector R1 and vector R2. Now let's see how to find the angle between two lines when direction cosines of two lines are given. Okay, see here we know that angle between two lines in Cartesian form is cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square plus B1 square plus C2 square into root of A2 square plus B2 square plus C2 square. See here what are A1 B1 C1 A2 B2 C2? A1 B1 C1 are the direction ratios of one line and A2 B2 C2 are the direction ratios of another line, right? See here in vector algebra we have already studied that relationship between direction ratios and direction cosines, right? That is, if L, M, N are the direction cosines of a line, okay, and A, B, C are the direction ratios of the line, then we have written L is equal to, A is equal to lambda into L. Okay, lambda is a constant. A is equal to lambda L, B is equal to lambda M, C is equal to lambda N. Right? So here two lines, right? So let's take L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines. Okay? L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines. Then how to find what is the angle between the lines? Okay? So here, let's substitute. Cos theta is equal to, here what is A1? See here, since they are direction cosines, and here we can write A1 is equal to lambda M1. Right? Here we have written, lambda L1. Okay? A is equal to lambda L. Similarly, here A1 is equal to A1, B1, C1 and A2, B2, C2 are the direction ratios of the two lines. Okay? So here we can write A1 is equal to lambda L1 and B1 is equal to lambda M1, C1 is equal to lambda L1. Okay? And A2 is equal to lambda L2, B2 is equal to lambda M2, C2 is equal to lambda N2. Okay, now let's substitute this in this equation. Okay, because here only direction cosines are given, direction cosines of two lines are given. You have to find the angle between the lines. Okay, see here, cos theta is equal to A1. What is A1? Lambda L1 into A2. A2 is lambda L2 plus B1 lambda M1 into B2 is lambda M2. Okay, plus lambda N1 into lambda N2 divided by here A1 square root of A1 square, that is lambda square L1 square plus lambda B1 lambda square M1 square plus lambda square N1 square, right, into square root of lambda square, that is A2 square, that is lambda square L2 square plus lambda square M2 square plus lambda square N2 square. Right? Okay. Simplify. Here lambda square L1 L2, in all the terms lambda square is common. Let's take it out. So lambda square into L1 L2 plus M1 M2 plus N1 N2 divided by, see here also, in these three terms lambda square is common. Let's take it out. So when we take it out from the square root, it will be lambda, right? So this lambda, here also same thing, lambda square is common inside the square root. So let's take it out. So lambda into lambda, that is lambda square, right? And okay, let's write one more step. Lambda into, okay, we have taken lambda square out from the square root. So here root of L1 square plus M1 square plus N1 square, and here lambda into, here also we have taken lambda outside. So lambda into root of L2 square plus M2 square plus N2 square. Okay. So that is equal to, here lambda into lambda, lambda square, this lambda square cancelled. And what is the value of this one? Here we know that if L, M, N are the direction cosines of a line, then L square plus M square plus N square is equal to 1. Right? Don't forget it. Remember, L square, L, M, N are the direction cosines of a line, then L square plus M square plus N square is equal to 1. So similarly, here L1 square plus M1 square plus N square, N1 square, that is equal to 1, square root of 1 itself. And here also L2 square plus M2 square plus N2 square, that is also 1. So here lambda square into 1, lambda square cancelled. So we will get L1 L2 plus M1 M2 plus N1 N2. Okay. So remember, if direction cosines of lines, two lines are given, how to find the angle between two lines. Okay, if L1, M1, N1 and L2, M2, N2 are the direction cosines of two lines, then angle theta is equal to cos inverse of, okay, cos theta is equal to this one, theta is equal to cos inverse of L1, L2 plus M1, M2 plus N1, N2. Next we are going through shortest distance between two lines. So first of all we will find the shortest distance between two skew lines. What are skew lines? Skew lines are the lines that are not parallel and do not intersect. Okay. So here let two lines, okay, these are the two skew lines. Okay. Vector R1 is equal to A1 plus lambda B1 and vector R2 is equal to vector A2 plus mu vector B2. Lambda and mu are the scalars. Okay. And here we know that vector B1 is parallel to this line, right? And vector B2 is parallel to the line, okay, vector R2. So here vector B1 and vector B2 are parallel to the line, these two lines respectively, okay. So here what about the vector B1 cross vector B2? Here in cross product we have studied that vector A cross vector B is perpendicular to both vector A and vector B, right? Vector A cross B is perpendicular to both vector A and vector B, right? And here see vector B1 parallel to this line and vector B2 parallel to this line. Then what about vector B1 cross vector B2? Here similarly we can write vector B1 cross vector B2 is perpendicular to both vector B1 and vector B2, right? Okay. Therefore, vector B1 cross vector B2 perpendicular to these two lines, right? Why? Because here this line is parallel to vector B1 and this line is parallel to vector B2. Therefore, B1 cross B2 perpendicular to B1 and B2. Therefore, B1 cross B2 perpendicular to these lines also. Okay. Therefore, B1 cross B2 perpendicular to these lines. Okay. Perpendicular, suppose it is B1 cross B2. Okay. B1 cross B2. Okay. So here, see, since these B1 cross B2 perpendicular to these two lines, we can say the shortest distance AB parallel to B1 cross B2. Okay. Shortest distance AB parallel to B1 cross B2. Therefore, now what is vector PQ? See here, vector PQ is nothing but vector OQ minus vector OP, right? That is here vector OP, that is position vector of Q, that is nothing but vector A2. Okay, so here it is vector A2 and vector OP is vector A1. Okay, vector A2 minus vector A1. And here we say the shortest distance AB is equal to projection of vector PQ, okay, projection of vector PQ on vector B1 cross B2. Okay, projection of vector PQ on B1 cross B2. Vector B1 cross vector B2. That is vector, what is the formula? Projection of vector A on vector B is vector A dot vector B divided by modulus vector B, right? So here projection of vector PQ on vector B1 cross B2 is vector PQ dot vector B1 cross vector B2 divided by modulus of vector B1 cross vector B2. Okay, that is equal to what is vector PQ? Vector A2 minus vector A1 dot vector B1 cross vector B2 divided by modulus of vector B1 cross vector B2. Okay, it is the formula to find the shortest distance between two skew lines R1 is equal to A1 plus lambda B1 and R2 is equal to A2 plus mu B2. Okay, next let's see how to find the distance between two parallel lines. Okay, so here are two parallel lines. Equation is vector R is equal to A1 vector A1 plus lambda vector B. Vector R is equal to vector A2 plus mu vector B. See, since these two lines are parallel and we know that vector B is parallel to this line, vector B is parallel to this line, the same lines. Okay, so here, okay, then let vector A1 be the position vector of S and let vector A2 be the position vector of T. Okay, then what is vector ST? Vector ST is equal to, that is position vector of T minus position vector of S, right? That is vector A2 minus vector A1, right? So vector ST is equal to vector A2 minus vector A1. And let theta be the angle between vector ST and vector B. Okay, we know that this vector B is parallel to this line, right? Therefore, here theta is the angle between vector ST and vector B. Okay, therefore by cross product we can write modulus of vector B cross vector ST, that is equal to modulus of vector B into modulus of vector ST, okay, into sin theta by cross product. We know that vector modulus of vector A cross vector B is equal to modulus of vector A into modulus of vector B into sin theta, right? Okay, so here that is modulus of vector B cross vector ST is equal to modulus of vector B. Modulus of vector ST is nothing but length of ST, right? That is length of ST. So here we can write it is simply ST, okay? And what is sin theta? See, sin theta can be written as opposite divided by hypotenuse, right? That is PT divided by ST, right? See here ST cancelled, that is modulus of vector B into PT, okay? See here, what is the distance between two lines? That is nothing but PT, right? So here we have to find distance between these two lines, that is we have to find PT, right? So length of PT. So PT is equal to modulus of vector B cross vector ST divided by modulus of vector B. That is equal to, here what is vector ST? Vector A2 minus vector A1. So here we can write modulus of vector B cross vector A2 minus vector A1 divided by modulus of vector B. Okay. So it is the formula to find the distance between two parallel lines. That is, distance between two parallel lines is equal to modulus of vector B cross vector A2 minus vector A1 divided by modulus of vector B.